Okay. So, what can we do? Where are my stats? Where are my stats? "30 FPS. 30 FPS? What? Where's the scene running so badly? Okay. Drawing gizmos is apparently extremely heavy. Holy shit. I wish I could have stats here. But here it runs at 1000. And it gets split when you have both open, and when I turn on the gizmos, it runs at 30. Yeah. Yeah. They're in my mouth. So. Oh, what did I press? What did I press? Did I press the right button? View import activity window. I thought I pressed, but maybe I missed it. Oh, so. We have array. So right now I am just projecting it straight ahead. But I'm still just using my list, but I did make a dictionary. And the idea there was that we can step in. Well, I kind of feel like the only way to really step quickly in the beginning is if you're outside of the world, and that's only like for debugging and looking around. Because otherwise, I feel like the octree should handle the steps, because each octree sphere, or not sphere, each octree octant is the step size, from what I understand. I mean, it's still kind of, I still don't understand what to do with the math really, because when you have an angle, the line becomes longer, right? So you can't just step the size of the thing. So there has to be some math there. Because like, this is one of the few times where I wish I had paid attention in school. So like, if you got a square, it's 16 wide or 16 tall, And across it's... No. Here it says 16. But here it's 22.6. So there's got to be some formula there, I guess. But we'll figure that out eventually. As long as I can just draw some pixels. Whatever. Actually, we might have to figure that out very soon. So we need an XYZ caster here, or for looper. But no Z. And I don't know if this is how you're supposed to do it, because it feels like insanity. But we're just gonna toss array on every single screen pixel. Luckily, I did plan on just having a 960 x 540 resolution. And that'll make it a lot easier, but 1920 x 1080, that's a lot of rays to step through every single frame. I've been trying to think of ways to like maintain the information that you've got and just kind of alter it, but I feel like that's difficult as well. But we'll get there when we get there. So for now, we'll do cam dot scaled pixel height, cam dot scaled pixel width, and then we're gonna do something like ray ray test equals cam dot ray. See, we've got screen point to ray and viewport to viewport point to ray, and I think don't understand what the difference is, but my theory at least is that screen point is orthographic view, but it also has camera mono or stereoscopic eye, which I think is probably related to having a VR setup. That's probably not something we care about. But I've never really messed around with this, so I don't know. Here you have a vector 3 and I think we'll do this. Vector 3 raycast target equals new equals vector 3.0. And what we can do then is we can do raycast target dot set instead of doing new vector 3 10,000 times frame. X, Y, 0. And do we need that? No. Oh, you have to do this before? Okay, so we need to do that. And then we do that. Because the set doesn't also return the value. And what happens then? Check for voxel vector 3. So what's happening here now is that don't want to debug there. We'll cry. So really, this part actually worked. It just kind of really sucks ass. So what we can do is we can just plonk this in here. And then what we need to do is we need to set this X and Y instead. And this apply should happen here. I believe. And now this is actually not good as well. This is just a set pixel. What you should do is you should, since this is like a batch maneuver, we should actually add them to a color 32 array, and then use set pixel 32 here, right before we do texture.apply, instead of doing set pixel like 10,000 times. But we're just trying to make it work, so this is fine. Now, what things do we need to change here? The step makes no sense. This should happen here, right? No, what I did before was I had a while loop, but I removed it. Just because the reason I removed the while loop was just so I could have the debug log log every single frame. So we need a while loop inside the 444 loop, I think. And that's gonna be here. Now, this we are for looping, and we're using the for loop to find the the octree that to check, which is also horrible. That's why I made a dictionary up there, so we can make that better. But let's just do this for now. It doesn't matter. It'll just run really badly. Perhaps we can make it run less badly after. So while timeout is less than 1000. Now here, this should just happen here every single time. We should reset that for every single pixel. This is where it gets horrible. No, the step needs to be inside the while loop. There. And the next thing we need to do is, right now we have a 1 times 1 texture, but that should be a 1920 times 1080. Color array should be 1920 times 1080. See what happens. Let's turn off draw octtree. Octree created. So we have even less information now. Before I managed to get a hit. Am I even doing the thing? Like, if this is raycasting right now, then it's not even affecting the frame rate. Raycast, there it is. Did the program freeze? It froze. It's not gonna unfreeze either. It's broken. Computer frozen. Unity not responding. Whoa. I'm missing something here, am I not? Where am I setting ray position here? How the hell did this work before? Like here we've got array test. That's just a this array test. Yeah. And then current rate position equals rate test dot origin plus step plus rate test dot direction. Oh, well, that explains a lot. We have while timeout is less than 100, but I forgot to put timeout in the while loop. That will help. I hope. Alright, let's try crashing it again. I hadn't turned off draw oct3, and I don't think I really did anything else. Now what? Check for voxel vector 3. Don't understand. Isn't this weird? There has to be something wrong inside my bounds check then. But I don't see how. Fuck. What am I looking for? So I do a bounds check for my rate position, and I check, am I inside this? Or yeah, we're looping through every single octree. And then I check the bounds of that octree. And if that is true, then I check for a voxel with a vector 3. But how is this, like, how can this happen? If position.x is greater than position.x minus half size. And half size is just what it sounds like. It's just size divided by 2. See? And we've got that too. like inclusive there. How is this possible? But we don't get anything there either. All we're getting is this over and over and over. Null reference exception. Oh, what the hell could be causing that? Wait. Wait. This is such a mess. But no, this... Is this wrong? This is what it's supposed to be, right? Maybe this is actually returning an incorrect value somehow. Let's see, I've never used tries before, really, in a way that made any sense. Try. And voxel equals, and then we do this. Catch exception. It's just a null reference. Is that all you type? You just type null reference exception? Oh, you have to add shit in between here. Fine. I'm so bad at this. I don't really know how to utilize this in a good way. But vector3 underscore pos check. Uh-oh. How far is this going to go on? I don't need to know this. Please. How the hell did we end up there? I don't see any errors anywhere. What's the problem? Is the problem when we find the right tree? Or what? What's going on here? What are we at right now? I value 1. What's happening? I don't understand. This is how it's supposed to work? Step over? It just never... Never gets past this. His content. Yeah, that's a bull. So what are you returning? Oh shit! Where are you now? No, that was on run gizmos. And now it still says I won. What the fuck is happening? Why won't it move past this? Is there an error here somewhere? This is like the weirdest thing I've ever seen. I've used this before and I've never seen it work like this. I mean, it managed to make it over here. Is it because it's hitting a null reference here? But this is why I hate using debugging tools. They make no sense. They're absolutely terrible. But yeah, 4 at 1. So it just never gets past that. But the fact that it makes it past this is just position stuff. So what about this then? Wait, have I forgotten? No. No. This should be fine. And we're using get check for voxel like 3. I don't see what the issue is. So where I was trying to do the try here, but this isn't where the issue is. I think the issue is here. But now. Feel free to stop. I wonder if I could add an application.pause there or something. Because now it's trying to print stuff. That's gonna crash it. Well, it shouldn't. Not really, but I don't know if I'm doing this correctly. Other crash. I wish it didn't do this to me right now. Unity, how to pause editor via code. Use debug.break. Pauses the editor. Let's try now then. I don't know if that is the issue. No, it still just crashes now. Oh, hello there. Null ref, null ref. There's a lot of different values here that are all null. Why is it null? None of these values should be null. Or at 47. Might have an idea. What if we do voxel equals new voxel 0? And we try without this again. Because it might be the case that the voxel doesn't have anything in it, and therefore when we're trying to access it, we're getting that. And it's not actually an array issue. But it's still freezing. Why is it freezing now? Oh, is it because of this? It's probably because of that. Not because of that. It might be that we're getting past that now, so it's here now. It's this. See how many times we have to start Unity. But why is it crashing now? Is it just because we're like actually raycasting now? Alright, so rebounds check. Fine. Check for voxel vec 3. That's fine. Get voxel. It's fine. Well, full array x plus y times 1920. Get rid of this. Then once we're done, we do texture dot set pixels 32 full array. That's what we're doing now, and then we're gonna do texture is 10 and 5, 10 and 5. What about now then? Like, I don't know why it's crashing, so it might just be that I'm doing too much. Like, this might not be viable. Index out of bounds. Yeah, this is 10 now. Yeah. Even with 10, it's running at terrible speeds. Oh, crap. A little bit strange that I don't see anything on the camera. Isn't it? Why can't I move this? I can move it there, but it doesn't move. What? I don't remember setting this quad in any way. No? So... Can't move it now either. What? Why do I have a quad I can't move in the Z-axis? Like now I can move it. But if I attach it to the camera, then I can no longer move it. I can move it Y and X. This is... I don't get it. There. So what? I need to put this as the camera inside the quad? Huh? And now I can't move. What the fuck is going on? What is this bullshit? This is the weirdest thing I've ever seen. Let's open the main project. I can't remember this being the case there. Because there I have everything inside there, but... like main camera, system controller. Has it always been like this? No? What? What if we make 2 empty game objects? I put you in there. There. That guy can move. Is it because of that? Okay. So the camera was set to 0's Z scale, and that makes it impossible to move. Children. Okay. Okay. Super. I don't understand why the camera was even set to that. Is that by default now or something? No? Okay. Okay. Oh, you got more? Hot soup, hot tea, Chinese solution for Chinese problem. Yeah. Let's make another voxel type. Called grass. Color is green. Brown there. Hello, Cat King. How's it going? Let's do else if I equals arc_tree list dot count. Does it need to be count -1? I am trying to program some voxel rendering and stuff, but I have no idea how or what I'm doing. Is there a color 32 dot? No. What about now then? Right now I am just raycasting, but it does not seem to run very well. Hmm. It keeps showing the same thing. Even if I, like, what I wanted to do was that if you go off where there's nothing, it should render nothing. It should just get black. Maybe this does need to be -1. Keep selecting the wrong thing. Main camera. There we go. Now it's showing when we go off the screen there. Drawing very strangely. What happens if I turn on my gizmos here? Hmm. I had imagined that it would render everything properly, but it's weird. Hmm. What if we try green point array? Now we get nothing. There we go. But it's really strange now. See, this is what I find weird. There should be voxels at the top. It should just be filled with voxels at the moment. There should be no air voxels. Because here, when we set it, I am checking if y is less than 1, and then I set a dirt voxel. Else I set a green voxel. So when I move in like that, we should just be getting, like, we should just be seeing it like this, like we're looking from above. So you should always get like a full green. So this is super strange to me. And you can see here in the texture that that's, even if it's super small, you can see that's what we're getting. And I see that the screen... Okay, so this is what the screen view means. It's affected by this much. How is it possible that we're getting an angle like that? I mean, I guess it is possible because we're casting in the top left corner, so they might have angles like this. But even if they do, that shouldn't matter, because we should still get a flat view. Super strange. No, I don't want to bug test any scripts. Let's try switching this back to viewport point to ray. It's still affected by this. But if we change this free aspect to 1920 times there, now it's fixed. But it's still weird. Like this I kind of get, where we're going through it, but why would it draw diagonally like that? Well, I might have an idea. We do have a pretty wide viewing angle, and we're actually checking like only the... Raycast target. See, here we're setting X and Y, and that's gonna be 5 to 10, and that's just up in the corner. So what if we do... What's 1920 divided by 2 minus 5? 955. What if we set this to plus 955? And an 80 divided by 2 is minus 2.5. Let's just go with minus 2. 538 plus 538. How can I not find anything now? Like now I'm inside it, now I'm past it. Yet it's not rendering anything? Google Unity viewport point to array. Viewport coordinates are normalized and relative to the camera. Okay, fair enough. Then we divide this by 1920. Steel Series became Razer without my noticing. Their Steel Series engine thing got transmuted into an equivalent that does a bunch of bloatware shit, just like Razer. Yeah. Yeah, Razer stuff is terrible. So unnecessary. How about now then? You find some brown there? I don't know if all these math F calls are super heavy. Really? At least when you're doing them like 4 million times. Okay, well it renders now, so let's try switching out the list. And instead we make a... We have a dictionary there. Octree dictionary. Octree dictionary. Dot add. New Octree. Well, first is the key. So that's gonna be new vector 3 1 f times x, 1 f times y, 1 f times z. and then the octree value, and that's gonna be this. Now here's the tricky part. Now that we use the vector like a key for the dictionary, if I want to loop through that, how do you do that? Octree dictionary. I don't actually know how to, like... New vector 3 x, y, z. Ah, wait, I have to Google it. C# dictionary. Okay, so it actually uses brackets. Really gonna need another. This is gonna be the biggest for loop I've ever made. XD++. sort of masochist gets a husky? Yeah, yeah. Imagine getting a husky and living in an apartment. Like with other people. So here, instead of iterating through this, what we need to do is if octree dictionary and then you access it with current new vector 3 math f dot lore current ray position dot x comma. Vector 3, let's say Lord ray position equals vector 3.0 and then here we'll do vector, raycast, floored ray position dot set. We'll set this. And then here we can check that. Then we do that here as well. And here as well. Now, the question is, what happens if I input a key that doesn't exist? Is that just gonna return false? Key not found exception is gonna be a thing. So basically we have to check if Lord ray position is greater than vector greater than or equal to vector 3.0 and do that. Let's see what happens. The given key 110 was not present in the dictionary. That doesn't sound likely. What about now? Oh, it's still... Because that should be... That should exist. This will get casted to floats automatically. So this here, when we're generating this, well, what exactly does this end up at? Because otherwise that wouldn't be accessible. Okay, fair. Y is always at 0. And for this, the Octree dictionary, this will be x times 0 times 1. So this will go from 0, 0, okay, 0 to 9, 0 to 9, 0 to 9. But here we are checking the dictionary there. So what we have to do is we have to check if floored ray position dot x is greater than or equal to 0, and floored ray position dot x is less than 1f. Well, it's less than oct3 world size dot y, because that's 1, right? So it has to be less than 1. But also we've got that there. That's interesting. Now it works. We're still raycasting in the same way we were before, but now it's running at 900 FPS instead of 100. Do we save and try making the resolution screen size again? Now, let's see as it runs at 2 FPS or crashes again. Oh, come on. Okay, it is drawing. It is running at 11 FPS. Okay, let's do this. Public vector to green size, and then we replace all of these with that, so we can just set it. The vector to int. There. And then we go and we find screen size and we set that to 960 times 540. And it runs at, again, 1.7 FPS. Why does it say 1.7k tries? 7 batches? How's there 3,400 tries in the scene? Is it counting? What is it counting? "19 patches." What? It's in controller. Alright, let's try that again. Viewport point to ray can only be called from the main thread. Yeah. I don't understand what kind of angle we end up with. Is this just based on the FOV? Because we've got like an FOV axis here. Vertical field of view is 60. I don't know how to translate that. I kind of understand. Like if you have a plane like this and you have a camera, you want the camera to view the plane, you don't have a distance from the plane, but you know how big the plane is, and you can set the distance of the camera based on the angle top to bottom. So that's what it is. Here to there rather. So how do you calculate that? Google, how to calculate vertical FOV. Yeah, we're calculating the vertical field of view with the horizontal field of view. Wow, dude, that's so good. How do we get the horizontal field of view then? Stupid ass. Someone says you can do this. On script. Public float FOB. Start equals FOB equals horizontal field of view. And how do we get that? I mean, if we just do... We should be able to just grab it, right? Like cam dot field of view. The vertical field of view of the camera in degrees. Yeah? Do you really need more than that? If you want to have horizontal field of view instead of vertical, you need this formula. Camera.field of view equals horizontal field of view. But the camera.field of view is already vertical, so... What? Camera.field of view times math f deg to rad. What are they doing? Camera.field of view. No. Cam.field of view times math f deg to rad. Camera height at 1. Math f.10. Horizontal angle. Oh, I get it. I think I get it. You can do this. You set whatever horizontal field of view you want. So if you want a 90 FOV, you just type in 90 FOV, right? That should work then. So I'm just trying to figure out how you would do this, and I'm thinking it's just like when you're gonna send a ray out, you just do you just place it as a cone, the field of view in front of you, and then you just do x divided by screen size, and then you just divide the field of view into that many parts and just send it out like that. Am I wrong? So then here, raycast target. We're doing ray tests here. So this is gonna be a new ray. So this is already a ray, right? Ray test equals new ray. Now, to rotate something up and down like this, you rotate the X. So ray test would be ray test dot direction. It's a get and an a set. Then we can do cam. Well, can we even get the camera? I don't think we can access the camera at all, but we can just try it. Cam.transform.rotation. Or transform.position, just because. Now, can we access that? No. We cannot get the transform. So what we need is public vector 3 cam position, public vector 3 cam rotation. And then here at the start of update we do cam position equals cam dot transform dot position, cam rotation equals cam dot Transform dot rotation. So that's a quaternion. Ah, shit. Ah. So I think we can do that. Set this as a quaternion. And then we get the rotation as a quaternion. And then here, when we set the direction of the ray, we can set it as vector 3 dot forward times camera rotation. I thought that was how you did it. So now you don't do that? I thought that was how you rotated things forward. Oh, shit. You can't do quaternion dot forward, but you can do quaternion times vector 3 dot forward. So why can't I do that? Does it have to be like the other way around or some bullshit? It has to be the other way around. Why? Oh, that's so stupid. Okay, so now we have a direction there, I guess. Then what we need to do, I guess, let's do float rotation step equals FOV divided by screen size dot y. Float rotation step age or x equals horizontal FOV divided by screen size dot wall x. I don't know if this makes any sense, but... Actually... This ray needs to be set inside here. Otherwise we're going to get very nasty results. Set the ray here. That'll set it as, or call it as, or whatever, declare it as little as possible. But the origin is going to be cam position and cam rotation, or cam rotation times vector 3 dot forward. Okay. But then I want ray test dot ray test dot direction dot x should be Man, I don't know how to rotate this. How do I rotate the direction? How do you even read a direction? And this is a bitch. I don't know if you can use mathf here either, though. Unity, how to rotate a direction. But they all just use built-in Unity stuff, so googling Unity doesn't really help. How can I rotate a vector 3 direction 45 degrees along the y-axis? Do you have a rotation matrix? I don't know. Do I? I have never worked with 3D before, so yeah, I was just looking at this. Someone said you can do that, or use Euler angles. So you can do like I don't know what I'm doing. I'm trying to like raycast on the scene, but I'm trying to parallelize it. But if I do that, then I can't get directions from the camera, because you can't use the camera within a threading situation. So I guess I have to get like the angles myself. That's just how it works in Unity. You just can't do it. I can't even access the camera's position. It just won't let... You can't use Unity stuff inside Parallel. Copy it. Yeah, no, it's a specific thing. If you use Unity's, like Unity stuff is not thread safe, it just won't let you do it. Anyway. Copy of the camera matrix. Might work. Well, that's kind of what I'm doing, I think. I mean, I'm setting the vector 3 of the camera, the position, and I'm setting the direction of the camera as just 2 vector 3s, and then I can access them in here. But I assume that's what you mean with matrix. I'm just not used to the word matrix in this. So, more advanced version. Matrix. We have a matrix 3x2 and a matrix 4x4. Holding matrix. Projection matrix. Is that the one? Set a custom projection matrix. Get stereo projection matrix. There's a lot of projection matrices here. Stereo view matrix, culling matrix, camera to world matrix, oblique matrix, world to camera matrix. Camera to world matrix. What do we have in there? We've got multiply point, rotation. All right. Let's see. Why is this one fighting me now? Where does this come from? When did I add system.numerics? Turns the matrix into a quaternion. Alright. I barely understand what a quaternion is. I know that I can multiply it by dot forward. That's pretty much it. Let's see. Then we've got that. Let's name it test matrix. That's a good name. And then ray test dot direction. Encodes a rotation, and you can multiply it with directions to rotate them. Yeah, I kind of understand that. And it just translates it into like local rotation space. So if you do rotate.up, it'll rotate it up locally for that object, more or less. Yeah. Anyway. Direction equals test matrix times vector 4. 0. No, it would be minus 45 or something. I don't know. Does this even make any sense, what I'm doing? Maybe we need the rotation. That's a quaternion. Well, maybe getting this to work makes sense, but I don't know if what I'm using it for makes sense. I'm just trying to raycast, and I'm trying to raycast across the entire scene just to grab voxels and paint them on a quad. It's not running too hot. That's why I was trying to parallelize it. Oh shit. No. There we go. There we go. I didn't type new, that was why it didn't work. I'll probably end up just switching over to just making a mesh. Right line below. Yeah. No, I've been Googling how to raycast for days, and I can't find anything that isn't raycasting in a shader. So at the moment, since I can't use what I was using before is you do ray test equals cam dot viewport point to ray, and then you just give it a normalized positions 0 to 1, and then it just gives you a direction based on the camera. But I can't use that here. I can use that if I want to raycast straightforward, but so I was just trying to recreate rays like across the viewport, and the only way I could think of doing that was to have a field of view. So you have, like, let's say a 60 vertical field of view, and then you basically divide that by the screen height, right? And then you use that as like the step for each pixel as you send the rays out. Am I on the right track or on the right track? Right. Okay. That's one way to do it. Now the problem is I don't think it's gonna... And using the camera matrix. So you think there's still stuff inside the matrix that I can use for this? Is that what you're saying? Transpose, set column, multiply vector, multiply point, get row, decompose projection. Because there's a lot of stuff here. Yeah, but won't that just give me the first forward direction? I was thinking of how to get like all the other directions. But maybe you're not done. I don't know. Yeah. Because I need to send more than one ray, right? So I need to get the directions for the ray for the entire screen. That's what I'm trying to do. And that's why I was thinking I take it and then I rotate it 45 degrees down, and then I just add 90 divided by 1080 degrees every single time to the direction. But we should be... I should be able to do that now with the information we have here. I just need to get my brain up to speed. So basically, I have my... It's also kind of weird, because if I understand right, the X rotation rotates you up and down. But that's because X goes that way, and then you rotate around that axis, right? So it makes sense. So what we need is... Is this line wrong? Well, yeah. That should be times vector 3 dot forward to get forward. Yeah, that's what I was looking at here. Let's see. I think you can do this. You do rate test dot direction equals quaternion dot Euler 0, no, minus 45 0 0 times rate test dot direction. That's, at least that's what it looks like over here. But here I'm a bit worried that the rotation isn't gonna... I mean, it does take float, so it might handle the decimals properly. Well, whatever. And then I was thinking... For Y, you would do... Because I have to set it here every single time. Because the ray has to be internal or local to the parallel or the thread. Otherwise, it'll keep messing with... They'll keep messing with each other. So if we then just do ray test dot direction equals quaternion dot Euler and here's where it gets a little bit tricky. We do rotation step y 0 0 times rate test dot direction. So now we set our ray here, and it's honestly already set. We don't need to do this line. Did I do? I did something. Because here, when I set the ray, it takes in an origin and a direction, and we're already setting the cam rotation times vector 3 forward, which should be correct. And it already has a cam position. So then if this is correct, if we take quaternion dot Euler minus 45 degrees. Well, I actually don't know if it's 45 degrees. It should be vertical FOV. No, FOV divided by 2. Yeah. What are you saying, LB? LB's cosine. Is this Breath of Fire 1? Yeah, that explains it. Where's Breath of Fire 2? Black Dragon. The Destined Child. Yeah, there it is. So we rotate it down by half of the FOV, and then we rotate it up by the rotation steps. And then we just need to maybe I should set that here. Because then we can set the... Is it Y? I think it's Y. Because Z, that would be that way, so that would just tilt the camera. So now we have to do the same thing here. Horizontal FOV divided by 2. And this here then should be rotation step X. So then the camera should pan down and pan to the left. And then as we're going through X, it should pan to the right, and then it should reset and pan up a little bit, and then it should keep going like this. And we should get something there, right? Step equals 0. Why is... Oh. Well, assuming we can use quaternions, let's see if it complains about using quaternions. No, this is the wrong project. There. Oh, well, what are we getting here then? It seems... Yeah, we're just getting key errors. How are we getting key errors? Sword ray position. Let me copy that in so I can read it better. Oh shit. Vector 2 UV equals vector 2. There's some line breaks. Yeah. There. Don't worry, I got it. Oh, it should be on the next line. All right. I fucked something up there. vec 2, vec 2, vec 3. Spelling error on the direction. Make it have a range. This is kind of clever. I didn't know you could do this. I've never really used lerp much. Oh yeah, lerp only wants to use floats, not vectors. Okay, so this X and Y here, this is just the screen point. Divided by resolution. UV equals math.lerp, and then you take the... Yeah, because this is already a normalized, and then you stretch it to -1 to 1. What does 0, 1 squared mean? What does that even end up as? I don't understand this. It's like, what's 1 squared? Isn't that like 1? Just notation? Well, yeah, I mean that. I know that that's a range. I mean the power of 2. Oh, you meant that it's 2. So it's X and Y. That's what it means. I understand. You see, I never went to school for programming, and I dropped out of university twice. So I don't know fancy stuff. And then direction is... What is going on here? Dot normalize? I actually ran into this the other day because I got angry that what was I trying to do? Yeah, I was trying to get like the normalized pivot of one of my sprites, because if you got the pivot, it just gave you a pixel value for the pivot on the whole sprite sheet. So I was trying to get it with pivot.normalize, but .normalize wasn't part of the sprite class at all, so so it was just normalizing it using the vectors normalize method, and it was giving me completely incorrect things, and I was angry for like a whole day trying to figure that out. But yeah, I don't understand what this does. Because the value that I got, it didn't make any sense to me, so I don't really understand what it does. Okay, so normalize is specifically for direction. Okay. What is it doing internally, though? A normalized vector maintains its direction, but its length becomes 1. The resulting vector is often called a unit vector. A vector is normalized by dividing the vector by its own length. Vector.length property. The length of a vector 2030 is approximately 36.0555. Feel like I'm missing something here. This is some method. How to calculate length of a vector? Is that what that is? Oh, no, there are way too many square root signs here. I don't want to. I want to jump on VC in Discord. Sure, I guess. You don't mind being on stream. Whew. This was intense, by the way. Oi. Where are my volume settings? Is that a volume setting? No, that's a volume setting. Yeah, I figured it was you. I've seen you around. Is this working?
Yeah. Can you hear me? It's working.
I can.
Yeah. Can you hear me?
I can.
I can.
I can hear myself as well.
Yeah. I'm gonna mute you on Discord, so I'll just hear you on. Yeah. I'm gonna mute you on Discord, so I'll just hear you on.
Yeah, no, I'm gonna mute you on Discord, so I'll hear you on. Yeah, no,
I think you have to mute my stream. Otherwise, you have to use headphones. Because otherwise, I hear the echo recursively. Well, I can mute desktop audio like that. All right.
Okay, so yeah, no, I'll just share my screen for a second because like instead of looking at the math, just looking at a picture makes the normalization like really simple. Normalized vector. Let's see. Can you hear me?
Yeah. I see it. Well, I could. Now it's gone. Now it's back.
Sorry, I just disconnected from the internet for a second. I'll share my screen again. Okay. So, can you hear me?
Yep. Can you hear you?
Okay. Normalizing, maybe. Okay. So, yeah, I mean, this one right here. You see this V vector right here?
Yeah.
It's a direction, right?
Yeah.
Every vector is a direction unless it's like a 0, right? But the thing is, look at the length. It has like a length of like, I don't know, 4, 5, I guess, 5, right? It's just like diagonal length. It's pretty long.
Yeah.
And directions you don't have to have it long, right? So this U direction is the same direction as V, but it's a different length, right? So for various reasons that you can think about later, the standard is to have a length of 1, which U happens to be here. So if you so normalizing it just means to take V and turn it into U, right?
Oh. Yeah.
So it's always on this unit circle. All normalized directions should be on the unit circle, if that makes sense.
Yeah. No, that makes perfect sense.
And the way you do it is you take each component of V, like, so it so happens that I know the length of V is 5 because it's 3 and 4, and that's a Pythagorean triplet. If you remember, a squared plus b squared equals c squared from like high school.
No, I don't remember that at all.
That's how you find the diagonal, right? The diagonal of a triangle. I see a triangle here, right? Like there's a line missing, but it's a triangle. So the bottom of the triangle is 3, right? And the height of the triangle is 4. Yeah.
Right. Yeah.
Okay. So I happen to know they deliberately picked this for this example because then 3 squared. Everybody who learns Pythagorean theorem, the first thing you learn is 3 squared plus 4 squared equals 5 squared, right? Like it's just a convenient triplet. It just happens to be, you can memorize it. So whereas the other ones, it's much harder, right? So that's why they picked this example. So take my word for it. The length of this is 5.
Okay? Right.
Yeah. So if you want to get U, what you do is you take 3 and divide it by 5, and you take 4 and divide it by 5. And then, and whatever those answers is, that's what U is going to be down here. It's 3/5 and 4/5. All right, that's the 2 coordinates of U now.
Yeah. I get it. Yeah, that makes perfect sense.
All right, so that's. But I didn't mean to distract you with the normalize. The normalize is like a side thing. You can probably leave it out and still get correct stuff here, but or at least normalize it later wherever it might matter. I just normalize things by habit. The really complicated part is the next line, which you were kind of wondering about. Sorry, that line. But the meat of it, right? Like inside the vector 3. Like why is that happening? That's the real question, right? Why is it uv.x, uv.y, and -1 in there?
Yeah. Yeah, I don't know.
Yeah. Okay. So
let's look. I could probably figure it out if I was looking at it a little bit more. But my
you were literally saying this to me before, so you already have it conceptually in your head. But
yeah.
So here's a camera. Okay, a camera can be represented by a view, this thing called a view frustum, right?
Right.
So it's got this near plane. So it's got this field of view, right? It's got a direction, and it's got this this shape called a frustum, right? That's implied by the field of view, the direction it's looking at. You know, the two field of views, the direction it's looking at, the far plane and the near plane, right? The far distance and the near distance of the camera. Okay. And I mean, this is a perspective camera, but that's what we're dealing with, right? So, and it also has this origin, right? The camera position. Okay. So, now there's two different coordinate systems here. We're looking at it now in a global coordinate system. Okay, right? Like it's like a camera. It kind of looks like a camera, right? Like it's a camera. It's like, you know, these video games that have cameras, these like little cones. You can actually like see the cone where the camera's looking, right? Like that's what this is, right? This is what the camera sees. If like in the world you walk into the shadow here inside the frustum, the camera sees you. Otherwise, the camera doesn't, right?
Yep. I think I actually get it. Like, because normals need to be positive, right, for them to be visible. And I see the -z here, so that's why the camera needs to be pointed the other way, I assume. Or am I wrong?
I'm not sure what you're saying.
Well, here it says the direction of the camera is -1, right? And that's kind of what I was assuming that.
Yeah, that's just a different coordinate system. So I'll tell you, okay? So there's two
All right.
coordinate systems. One's a global coordinate system, which is what you see here now. But in the camera space is another coordinate system. So that's like relative to the camera, right? You remember Einstein and relativity? Everything is relative, okay?
Yeah.
Right? So relative to the camera, the world does not look like this. It kind of looks like, let's see if I can find a picture. You're looking, well, I can't find a picture, but you're kind of looking at, it just looks like this square, essentially, right? You're just looking down that square.
Yeah.
So let me find a picture. I'll just, I can find a picture. 1 second.
Disconnected again. You'll find a picture.
Did I disconnect?
Yeah.
Oh, I disconnected again. Crap. Sorry about that. My internet's terrible. Okay. Oh, share my screen again. So, learnopengl.com has a great tutorial. It's not going to be that helpful to you, except. Oh man, can you hear me?
Yeah, it's a little bit laggy, but.
Can you hear me? Testing. Oh,
yeah.
Can you hear me? Oh crap! All right. So this is gonna help. This thing can help you conceptually. Wait, this is not the. Okay. Camera space. I can't get a view from the camera. A view from the camera. This one's almost right. Okay. Here we go. Here we go. This one is right. Okay. Can you see this?
Yeah.
Okay, so imagine this is the view frustum here. Okay. From the camera, this is what the world looks like. Okay.
Yep.
So like in camera space, so there's a few different types of camera space. One of them is called NDC, normalized device. 1 second. Normalized device coordinates. Oh, I didn't mean to do that. Here we go. This is probably the page that I was looking for. Yeah, here we go. Here we go. This page. View space, right? So from the camera, everything kind of looks like this,
Yeah.
right? But this thing is essentially the near plane. Does that make sense? Like this square is equivalent to the near plane. Yeah.
Right. Yeah.
So in camera space, you can make a coordinate system where that's just UVs on this plane.
Right.
Make sense?
Yeah. Yeah.
So that's what UV is. It's just 0, 0 here and 1, 1 here. At least that's OpenGL. DirectX uses 0, 0 up here and 1, 1 here as a convention. Okay, does that make sense?
Yeah.
Okay. So now, to get from UV to world space, meaning like you want to know, if I pick a UV here, what is the direction in the world? Okay, that's the question. So the answer is, first you have to pick a direction in camera space. And how do you do that? Well, let's go back to the frustum. Let's find a good one ahead. Right, so you pick a UV on this thing, okay?
Mhm.
And you then say, well, any UV on here with a negative, so -1 is the forward direction. Well, actually, so you see that -1 that I put
Yeah. Yeah.
there? That -1 is assuming that -1 is the forward direction. -1z is the forward direction. So it actually might be wrong. I don't know what Unity does.
Yeah, that's
okay,
the one
so-
I was not sure about, but I don't know what Unity uses either.
Yeah, so whatever Unity does, you have to use the other two axes for the UVX and UVY. You understand what I'm saying? I'm not sure how to do that easily and succinctly with like vector.forward, right? Like using vector.forward, I don't know. But you could also just Google what Unity uses for forward.
Yeah,
that's probably
if you use vector3.forward, that's 001.
I see. So put a one in there instead of a -1.
All right. All right.
So what we want is a direct. So here is the origin, and what we want is a direction from the camera that's like pointing this way.
Mhm.
Well, pointing this way is, you could just put a -1 in there because it'll point that way, right? And the question is, starting from the origin. So you want a line going from the origin to the view space to a spot on here.
Yeah.
Okay. So by picking a UV, so and the center of this thing will be 0, 0, -1, or
Yeah.
sorry, 0, 0, 1. Does that make sense?
Yeah.
All right. So so that's why I switched it to the -1 to 1 range, so that the center is 0, 0. Does that make sense? Okay.
Yeah.
So any other spot on here will be a spot. Will be a direction from the origin to out, from the origin to somewhere on the plane, and then and that direction just continues forever. Does that make sense
Yep.
so far? But this is
Yeah.
all in camera space. Okay, so once you get this camera space direction, and then you normalize it if you want to, then you can use the camera matrix or the camera quaternion. It's up to you. To multiply that direction and get a world space direction.
Right.
And then you can use that for your array.
Right.
Now, another way to do this is with trigonometry. You can like literally, I had a picture here before somewhere, but you can literally, oh yeah, it's over here, right? You can ignore the matrix.
Oh.
You can start using cosines and tangents and figure out everything. It is not fun.
Oh yeah, that's.
So
I never got into
just
those
using
things
the
in
camera
school,
matrix.
so.
I mean, even people who got into them, like I was into that. It's just not fun to work it out. So
Yeah.
it's just torture. So yeah, that's where the camera matrix exists. Okay, and yeah, so the camera matrix is a camera to world matrix. It's a matrix that if you multiply directions or positions that are in camera space, it will then give you a new vector that is in world space.
Yeah.
The reason you don't have to understand how they work. That's the point. It's just an object that does that, right?
Yeah.
And it's just a nice thing of linear algebra that matrices do that and quaternions do that. So quaternions only encode direction. Matrices can actually do direction, translation, and scale all at once. So that's why a matrix exists. But we only right now we only care about the direction. Well, you'll also care about where the rays originate from, right? So you'll eventually you need the origin too, right? The origin is also going to be defined by the UV on the space. All right, so you're going to want to eventually multiply that same UV. So let me just show you how that would work. If you do camera matrix, right, times so camera matrix is always 4 by 4. Okay? So the problem is that directions and positions are vector 3s, right? And so if you have you have to multiply with a vector 4. And so for direction, it's always like this. Right. So world direction equals that. Okay.
Yeah.
And for position, well, let me just paste this in somewhere so like you can get at it. Okay. Now, and for a world position, if you want to get a world position from this, you would have position comma 1. That's all you need to know. Okay. So when you does that make sense? And sorry, this direction is camera local direction, right? It's always camera forward. You know, vec3.forward.
Yeah.
Would be like what relative to wherever the camera's facing.
Yeah.
Right? So camera local, and the position is relative to the camera origin. So if you wanted to get a position from that UV, you would do something like first you would get the direction, right? Camera local direction would be you know, vec3 uv.x, uv.y, and 1. Okay, not -1, remember? Okay, and then in order to get the local position, you would say, well, the origin of the camera is 0, 0, 0. Okay, plus direct local direction times near distance. Okay, what the camera has a near distance float, right? Right, that defines the frustum. Does that make sense?
Kind of lost me there on the near distance.
So the frustum, right, has a near plane. So the camera has this near. It defines where the near plane is by distance. So every somewhere in the camera object in Unity, there's going to be a float that defines how far the near plane is from the origin. Does that make sense?
Yeah, I think the near plane was what I was trying to kind of calculate using the FOB, right? Because the further away the near plane is, doesn't that change the FOB, or am I confusing this with something else?
Well, it depends. It depends what you constrain, but the way it is conventionally constrained, no. The FOV is just an angle, and you can take this square and make it further away. And, right, like it all depends. You can vary the distance of the near plane from the origin, and it'll slide, right? You can make this further away. Like this square here is just a plane that's farther away, right? It can slide.
Yeah. So it's
the field of view, right? This angle, the shape of this frustum goes on forever, right? It stays the same in terms of angle.
Yeah, this is just the culling space, just cull everything outside of this.
Yeah, exactly.
Yeah.
It's not just culling. This is the entire view of the camera, right? The camera's entire world it only sees what's in here. Yeah.
Right.
So culling is like an optimization that you don't even have to look at anything outside the camera's view space, right?
Yeah.
So the point is, there's this near distance So like again, like you can define a camera many different ways, but the standard way is that a camera is defined by its origin, its field of view, and the near distance and the far distance, and its direction.
Yeah.
Okay. So
Yeah, makes sense.
and you can turn that into a camera matrix, which just right, like you don't do that. Unity does that for you. But if you were programming an OpenGL or something, you have to do that yourself. So the point is, if you go to the camera object, there's going to be somewhere something called a near distance.
Yeah.
Does that make sense?
Yeah.
Now, so going back to here, we have local position. Well, we know the position is going to be on this plane somewhere, right? Because we're asking, oh no, we could always just set the origin at the eye, at this place, right? But then there were, you could just set the distance. You could just set the origin of every ray over here, and just done with it. Okay, you could do that. But if you did want to set it properly on the near plane, and there might be problems with not doing that. There could be some problems, but mostly the reason why there's such a thing called a near plane is two reasons. It's conceptual, that the entire world projects onto this near plane as an image, just like in some cameras, right? You had some cameras had their image projected behind them, and in the eye it does happen behind them, right? And it's like it depends on the focal length and the whole, right? So like conceptually, people like having the square, and if there was no near plane, the square would be at infinitely small at the origin, and you wouldn't be able to conceptualize certain things. And the other reason is because in rasterization, or even in ray tracing, you usually want to like render this thing called a depth buffer. So like you render the image, and then you render for every pixel how far away it was from the origin. And you start running into problems of like, it's really important to get that depth to be as accurate as possible. And in the olden days, they used to have like 16-bit depth buffers for performance reasons, and that wasn't enough, right? And then they had like 24 bits, and now you have a choice between like 24 and 32-bit depths. But even 32-bit is not enough. If you're looking at a vast world, and there's two mountains that are really far away from each other, if you got the wrong depth buff, if the depth buffer cannot differentiate the two mountains, they're going to start fighting with each other. Have you ever seen Z fighting?
Yeah, I understand.
So that's why. So what they did was they basically cut the world up into these little sections. So like you make the near, if you start running into that problem, you only start counting the distance from the near plane, and therefore, if you start running into the problem, there's not enough bits. Either you take the far plane and you make it smaller, or you take the near plane and make it farther, right? And therefore, you'll have less information to store, and it's possible to store it. Does that make sense?
Yeah.
And if you do need, and there's something called depth healing, where you can just render multiple times at different depths, like with different near plane, far plane, so you can.
And it's gone. He's back.
No matter what. Oh shoot! Did I just disconnect again?
Yeah.
Anyway, I hope that's enough to get you started.
Well, hopefully. I mean,
I know I say this because I gotta run. I would help you out, but maybe another day when I'm available. But I have to run now.
yeah, no, I appreciate it. I'll just try to see if I can make any use of this information, if I can remember everything.
Yeah. So I'm pretty sure I remember you talking about something like this, right? Like you were trying to get this angle, start with this this forward direction, and then go 45 degrees down and 45 degrees up, and make the XY go somewhere in between those two things based on the X and the Y.
Yeah.
Right, and that's exactly what this is. Right, that's what this is. Except you don't have to deal with angles. You just deal, right? You deal conceptually with the UVs and the same thing, right? You don't say 45 degrees and 38 degrees. You just say what percent of the way is it from the bottom to the top, right? That's what a UV is. Does that
Yeah.
make sense?
Yeah.
And you don't have to deal with any specific angles because you start from the center, right? So the center as right, like you're basically starting from because you make these UVs -1 to 1, like 0, 0 is the center, right? So you don't have to specifically use any particular angle as well. So there you go.
Yeah.
You don't even have to you don't even have to deal with a field of view if you just use the camera matrix to do the right. Once you get this local direction, you can then convert it into a world direction. Not have to think about the field of view. The field of view is a number somewhere in that matrix, and you don't have to care about it.
All right. Yeah, I'll try to figure something out with this. So thank you.
Any last questions before I run?
No, not really. I think I just have to sit and mess with it a little bit.
Already.
Figure it out. Practically a little bit.
Yeah. Have a good one.
Yeah, you too, dude. Picture? Question mark? No pictures. No, someone was just helping me out. For Discord. Now I need to copy that out. I need to probably take a little breather. And remember what we were doing. All right, so this is what you get. You get the camera to world rotation. So that was it. Like I understood all of the normalization and the UV and stuff. So I've dealt with that before. But I've never even come into contact with matrices or really rotation at all before. So I've done no 3D stuff, but basically the rotation should because you get the direction. Yeah, you get a normalized rotation based on the UV resolution. Yeah, no, I think I get it. Basically, we have to calculate this in here. And what we need is... we need the resolution, and that's just screen size, right? And you can't lerp like this. You have to do 2 lerps. I actually hate that you can't do this. Like it... I would have assumed that you could do it with the normal lerp, like with math. Don't I have math? There's no lerp here? Nope. So it's only via mathf that you can lerp. And it only takes floats. You'd have to do just... well, you can do uv.set, right? uv.set mathf.lerp uv.x uv. Well, no, what am I lerping? 0, 1 uv.x mathf.lerp 0, 1 uv.y. No, it's not 0, it's -1. -1. And now I'm creating my arch nemesis, which is the fucking -1 to 1 screen normalization that I've been fighting for ages in my shader for 2D stuff. Now we have a direction, which is... oh, it's just big N. Okay, no, you can't do it in that order, you have to do this. And then you have the test matrix dot rotation times direction. And there we have our ray direction then. Why is everything so weird? There. And then raycast target, that's just going to be direction. Oh. Here's our ray test dot direction. equals direction. Now, the one thing I am a little bit confused about is the last thing we talked about, where with an airplane, so but that's something I can deal with later. It doesn't really matter right now. Because right now I'm just setting it to raycast from the camera position, which is the camera's physical position. And that isn't taking into account the flipping plane. But also, if we have a clipping plane in that sense, then when we're raycasting, well, I mean, I don't feel like we need to cast rays that far, but I guess you could always use the far plane distance as like the max step length. But that feels, I don't know. I mean, maybe you should be doing that, right? So, alright. Am I using this anywhere? Nope. You can comment that out. And this also wrong. So we should be raycasting correctly now, I think. Let's try it. Now we're still doing this. Did I fix that just now? I'll be right back. Now what I would like to do is here I am setting voxels. Man, how do you check every other? I kind of only know one way to do it. You do if I don't know if this makes any sense. If y divided by 2 is not possible, we have to cast this to a float first, I guess. Well, actually, I think it does that stuff automatically if we do that. If y divided by 2 minus mathf.floor y divided by 2f equals 0. Then we draw this. But I want this to be x. Else we draw that. That should give us every other. Now let's see what it says. It says that it's running at 9 FPS, 0.4 FPS. That's what we want. But I also know that I think I've... Red count. It is set to 2 though. No, it's running it. This is very surprising. It's running so poorly. Oh, this is an issue. Think. Is it? Yeah, these are global. Those there. X. That should be fine. Well, it is, but it's still running at 0.4 FPS. Eight thread counts doesn't help either. Really weird though. Running this badly at 960 540. At this point it was almost running better when it wasn't parallelized. It's always fun. Let's try unparallelizing it. I don't think that's gonna run any better. It's probably gonna crash it. Runs at 7. That does run better. Wrong game. No, it runs at 9 now. It runs better parallel. But it still runs incredibly poorly, so... How? Oh, wait, what? Wait, what is... What if we do this? Math F. Well. Vector 3. debug equals new vector 3 math f dot floor minus 1 minus 1 math f dot floor minus 1.2 f, and then math f dot floor 0 minus 0.6 f. No, I didn't. Oh, I don't need to actually make it. We can just debug the log. Print it right away. Does it get floored down, or does it get floored towards 0? It gets floored towards -2. Alright. So it gets floored down. Okay. That's good. Still find this odd, though. Because I'm checking if floored array position .x is greater than or equal to 0. Right? Then how can I access this dictionary there? The only thing I can think of is that it's getting accessed here. So I guess we can try that. And put another if statement here that's separated. But usually it's good about that. Like this. Because if I go through here now, it should just skip. Like nothing should happen. It just shouldn't be able to do what it's doing. Oh, it's still doing it. Here? It's not checking minus anymore. But it's... Well, no, it checked minus there. It could be... Let's see here. Want to see my voxel engine? Sure, I guess. This. Floored ray position. This needs to be inside the parallel. Are you stealing my IP address now? Yeah, seems alright. I mean, I don't know that much about voxel engines. I'm just trying to figure out the basics right now on my own. So I can't really say, to be honest. But seems fine. I mean, it draws, right? Need to add placing and removing blocks. Yeah, I mean... Just the rendering is just one step. You need to actually make something out of it. Right? So... If Oct3 world size is 1, and I demand that this is less than Oct3 world size, how can this be like 5 or 4, whatever? And well, we just solved that. It was because I'm parallelizing it and it was being set outside, so it was accessing things it wasn't supposed to. That's why. So now it should be fine. There, yeah. But now we got some funny things going on. Why is it doing this? I had this issue before as well. Oh, is this also set outside? Oh, come on. Yep. God damn it. But I would prefer resetting these as rarely as possible. Do I use chunks? Well, kind of. I'm using octaries. And they are technically chunks. Well. I was thinking... we set them down there, but we can reset them here. If necessary. There. And vector 3 direction also. Set that here. Equals vector 3.0. But I'm literally just trying to make it do anything. Like, right now I'm trying to raycast to render stuff. And I don't even know if it'll be viable. I'll just switch to doing standard. Standard meshing, if this doesn't want to work. And it does not look like it wants to work, but there might still be options, because I'm doing a lot of things. Like, we're doing a lot of checks, we're doing a lot of flooring and stuff, casting, and there might be ways to speed it up, but it's just that it's running at like the absolute worst frame rate ever, so I'm not sure there's any speeding up to be done. Well, maybe. Well, no. I looked at the frame rate and I was like, that's not that bad, but it's terrible. Yep. Oh, it's working more like it should, at least. I'm getting some wave shit here. It runs... It runs decently when you're close. But that's because the rays don't have to traverse. So, I'm not doing any... Also, they're supposed to be cubes, but... This, yeah. We'll have to figure that out. Got my frame rates to reasonable level using occlusion queries. I barely even know what that is. I'm only a 2D developer normally, and I don't do any occlusion and nothing like that. I haven't even done rotations and stuff, so this has been really all very new to me. But like I was saying, I'm not doing any optimization for the steps. It's actually supposed to go in. It's supposed to go into the octree and then just basically ask the octree for the next place to go. So right now it's actually marching by the smallest value, which is my voxel size, all the way. So that might help, but the problem is that it's running at 200 FPS, and I'm only rendering a 100 times 50 resolution texture. And I need it to be at least 960 times 540. And even with 8 threads, it only pops up to 300. And you can't really go, well, 12 counts. For my other project, it didn't want to go up to 12. My CPU. So if we go up to the 640 360. Is that even gonna run? Let's go with 8 threads right away. Point clamp. Running at 4 FPS. Very cool. Then we lower the Y. And now even at very small distances. What's happening? There's something. Still running strangely. But as you can see, I'm not taking like any direction or anything into account, so I don't really know where to go from here anyway. I do know that it runs like trash though. Oof. But I think I'm pretty much done for today. I'm pretty tired. At least we're rendering a little bit more. We're making a little bit of progress. But we'll try to implement dynamic step sizes. I'm just not entirely sure how to do that. But there should be a way. Like I'm dead sure that there's a mathematical way to do it, because once you hit a square, we can calculate where in the square we are, and even though we have a direction, that's what makes it weird. But I think I kind of understand how to... I think that was like part of what he told me. The length. Is you can calculate based on the... if you have the position and you have the distance, you can calculate the length of the vector, I think. And then we can just use that as step. I also don't think it would actually help us in this case. What I can do here is I could calculate how far outside of the world we are, and that could be our first step as well. But even then, I think that wouldn't really help much. Might help some, though. But yeah, we'll stop there for tonight. Tomorrow is New Year's, so I might do a stream on in the afternoon, in the evening. But we'll see. Anyway, until next time, thanks for hanging. Have a good night. Bye-bye.